Here are a few questions from the paper Classical Mechanics. We have to analyze them one by one. The first question is define escape velocity. Escape velocity is the minimum velocity required for an object to be projected to overcome the Earth's gravitational pull. Suppose an object is moving with this velocity, it can be escaped from the gravitational pull of the Earth. Once if you project the object in the upward direction, that object should be escaped from the gravitational pull of the Earth if it is moving with this velocity v equal to root of 2 g capital M divided by r. You know that g capital M by r square is small g and g capital M is g r square. Now this is modified as v equal to 2 g r square divided by capital R, that is equal to 2g r inside the root. This is another one form. Usually the escape velocity of the body to overcome the gravitational pull of the Earth is 11.2 kilometer per second. This is the escape velocity of a body. Then the second question is define orbital velocity. Orbital velocity is the velocity at which a body revolves around the other body. And the orbital velocity v equal to root of gm divided by r. G gravitational constant, this is capital G. Capital M mass of the body, r capital R radius of the orbit. Third question is what are communication satellites? Communication satellites transmit information from one part of the Earth's surface to another. There are two types, the passive system and the active system. A passive system reflects signal from the transmitting station to the receiving station. In the active system, the signals from the transmitters are received by satellites and undergo amplification in the satellite. Then it is again transmitted to the ground receiving station. The fourth question is define the term scattering angle. The angle between the incident beam and the outgoing scattered beam is called the scattering angle. If it is a incident beam and this is the scatterer, in the absence of the scatterer, the particle may be transmitting like that. Once the effect of scatter is realized, the path traced out by the outgoing particle is having some deviation. This angle is called scattering angle. What do you mean by scattering cross section? The area available for scattering is called scattering cross section. The cross section can be classified as differential scattering cross section and total scattering cross section. Sixth question is define the term differential scattering cross section. It's a ratio of the number of particles scattered into a unit solid angle in unit time to the incident flux. This is a definition for differential scattering cross section. Suppose a number of particles are coming in a beam and approaching a target. After the scattering, we are interested about the scattered particles. The number of particles scattered into unit solid angle in unit time divided by the total number of particles incident will give the information about the term differential scattering cross section. And the seventh question is define total scattering cross section. The total scattering cross section is the integral of the differential scattering cross sections. Sigma total equal to 2 pi integral of sigma theta sin theta d theta. Here the limit varying from 0 to pi. Usually the cross section is measured in the unit of Born. Unit of cross section. Unit of cross section is Born. BARN. 1 Born equal to 10 power minus 24 centimeter square. The eighth question is what is meant by impact parameter? The impact parameter B is defined as the perpendicular distance between the center of force and the incident velocity direction. We will go to the next ninth question. Define Hamiltonian of a system. We know that H equal to T plus V, summation of kinetic and potential energy, whereas Lagrangian is T minus V. The Hamiltonian H of a system is defined as summation over I, Pi Qi dot minus L. L is the function of position, then Q dot velocity and time. Write down Hamilton's canonical equations of motion. Qi dot equal to dou H divided by dou Pi, whereas Pi dot equal to minus dou H divided by dou Qi. These two equations are called canonical equations of motion. And see the 11th question. What is meant by parking orbit or stationary orbit? The orbit of the artificial satellite in which its period of revolution is equal to the period of revolution of the Earth is called parking orbit. Suppose a satellite is making its orbital motion, then the revolution time of the satellite, period of revolution, that means the time taken for one complete revolution is equal to 24 hours, then such orbit is called as parking orbit or stationary orbit.